Hello, during this session I'm going to be talking about binary stars. These are stars which go around in pairs, which is actually not as unusual as you may think. 80% of the stars in our galaxy are actually binary stars. We've got visual binary stars. This is where we can clearly identify an angular separation between the two stars visually. And what we normally have here is that there's normally a brighter star, the visual binary, and this is known as the primary star, and a much dimmer star, which is considered the secondary star. Now, by looking at the orbits of two stars, by recording the period of revolution and the separation, it's possible to calculate the combined masses of the stars using Keplerian physics. This isn't something you need to do for the IB course, but it's a useful enough fact to recognize that we can measure the period and measure the average separation and use that to calculate the combined mass of the two stars, which could be useful for you if you decide to study binary stars sometime in the future. Thankfully, it's not part of the IB examination. They do expect you to recognize something called a spectroscopic binary. Now, these are binary stars which, because they are so close to each other, we can't distinguish them visually as a binary pair, but because their orbital velocity is very high, what we can do is we can look at these using spectrometer, and we can observe a Doppler shift of the star spectral lines. So the binaries are detected in this manner, and this is known as spectroscopic binaries. So we can see here, if we look carefully at the diagram, I've got star A and star B, and at different stages of their rotation, there's Doppler shift, there's no Doppler shift, there's Doppler shift, there's no Doppler shift, and therefore we can distinguish between the two stars. And obviously, because we can look at things like the spectral lines, we can work out which is the high mass star and which is the low mass star, and which is orbiting around which. So as we can see, if we have a sequence like this, I've got two binary stars. They're both rotating around a shared center of mass, but the high mass star has a much smaller orbit, the low mass star has a much larger orbit, and the observed spectrum, we can see there's a shifting in the pattern, and that shifting in the pattern is because of that motion. There's a third type of binary stars, and these are known as eclipsing binaries. And what happens with an eclipsing binary is that normally although they're variable, the variable amount of intensity is due to one star eclipsing the other. What I can see here is as the small star goes in front of the brighter star, that eclipses are there and will causes a reduction in total brightness. And when the small star is eclipsed by the larger, brighter star, there's a small dip in brightness. So eclipsing binaries are seen as variable stars, not because of the light of the individual components varying, but because of this self-eclipsing process. And those are the three types of binary stars.